First, we'll introduce hardware lifecycle management. Hardware lifecycle management is also known as the hardware asset management, which is a subset discipline of IT asset management, specifically related to the hardware portion of IT assets that deals with managing the physical components of computers, computer networks, and systems from acquisition to disposal. The hardware lifecycle comprises 5 phases. The first phase is planning. The planning phase includes designing the strategic plan, security policy, and acceptable use policy. The strategic plan includes the designation of a responsible individual and a budget for hardware asset management. The security plan relates to security controls in place for the hardware asset management and plan for meeting strategic security objectives. The security policy addresses how security concerns will be incorporated into the hardware lifecycle. And finally, the acceptable use policy describes how users are allowed to use the hardware assets. The plan should include guidelines for hardware selection, methods for identifying and controlling for security vulnerabilities, and the classification scheme. The planning process should result in the definition of the mission, overall strategies, objectives, measurements, and prioritization for the hardware asset management in the organization. The second phase of the hardware lifecycle is acquisition. It is a process of acquiring hardware. It includes request and approval, vendor relationships, acquisition, and receipt of the hardware. The acquisition process should be designed to meet the four specific objectives, including gaining the most value from expenditures, strategic planning for system and application upgrades, reducing risk of data loss and breach, and disposing of assets in a cost-effective manner that secures data and meets recycling goals. The next phase in the hardware lifecycle management is deployment. Deployment refers to the preliminary steps taken prior to the software installation, followed by the installation of the hardware. The deployment process involves ensuring that any software running on the new hardware is subject to security hardening, such as changing the default vendor passwords and applying secure configuration settings. Each hardware item should be categorized based on its security impact. In addition, each item needs to be included in a master register, and the register should be completed and protected. The fourth phase is management. Once equipment is deployed, it needs to be maintained and managed. For larger companies, tracking of hardware assets is a key task. It often has an entire department devoted to IT tracking. Asset location technologies such as RFID can help organizations ensure that critical assets remain in authorized locations. The National Institute of Standards and Technology's special publication provides detailed guidance in the area of tracking an IT hardware. Preventative maintenance is high on the list of tasks to be performed. The simplest approach is to schedule maintenance in accordance with the supplier and manufacturer recommendations. Particularly in large organizations, it might be cost-effective to attempt to optimize the maintenance program. For example, IBM offers a solution called Predictive Maintenance and Quality. It uses information collected about products, processes, and assets to optimize maintenance schedules, production processes, and product quality. The last phase of the hardware lifecycle management is disposition. The disposition phase is an important part of the IT hardware lifecycle. It includes destruction, recycling, and redeployment of the hardware. When hardware items are to be destroyed, it is important to securely destroy all information stored on that hardware. Whatever the type of disposition, lifecycle management should include planning for the likely dates and time when disposition decisions need to be made on various equipment. The table here on the slide shows the average lifecycle duration of common hardware. Next, we're going to introduce office equipment. Office equipment includes printers, photocopiers, fax machines, scanners, and multifunction devices. These equipments are often attached to a network that provides opportunities for threat and so need to be protected. There are numerous potential threats to office equipment. There are standards bodies that provide a list for potential threats and vulnerabilities. Most office equipment devices contain some processing power and storage capability. In the office setting, such devices are frequently attached to a network. Much of the devices are both assets to protect and opportunities for threat. Often such equipment is not provided with the necessary security controls and meet risk management objectives. The next vulnerability is information disclosure of user data or configuration information. Three potential sources of this vulnerability are print, fax, or copy scan logs, address books, or mailboxes. And the next vulnerability is denial of service attacks. Multiple function devices can be vulnerable to a number of denial of service attacks. Such vulnerabilities include sending multiple bogus print jobs to exhaust paper resources and tie up a printer, modifying settings to make the device unusable, stopping or deleting jobs, and setting the IP address of the multiple function device to the same as the router, causing routing confusion. And then the next vulnerability is physical security. Physical security is crucial. Proper physical security is needed to guard against a number of threats, including making modifications to the global configuration through the console interface, sending unauthorized faxes, obtaining printouts or faxes that do not belong to them, and physically removing the hard disk which might contain print spoof files and other information. And the final set of vulnerability is operating system security. This is another general area of vulnerability of the multiple function devices. Many office devices run an embedded commercial operating system. This renders the device subject to the same threats and vulnerabilities as many other computer devices running on the same operating systems. The guidance on auditing and securing multifunction devices provides a useful checklist of security measures that an organization can take to protect its multifunction devices. The checklist is summarized here in the table. The Standards of Good Practice for Information Security recommends that sensitive information stored on office equipment be securely destroyed, for example, by using deletion software or physically destroy the hard disk drivers. This should be done before an equipment is decommissioned, sold, or transferred to an external party, such as a leasing company. This is an important security area that should not be overlooked as part of the organization's security program for office devices. An excellent source of guidance in this area is the National Institute of Standards and Technology special publication, Guidelines for Media Sanitization. The document defines media sanitization as the process of rendering access to the target data on the media infeasible for a given level of recovery effort. It defines clear, purge, and destroy as three secure actions for sanitization. Based on the risk assessment for an office device, an organization can assign a security category to the data on the device. Then the organization uses the sanitization and disposition decision flowchart to determine how to dispose the memory associated to the device.